I have the privilege to be a part of sales, head of finance, lead the product management, and sometimes when I'm extremely happy or extremely lucky, I even get to write a few lines of code. Wearing these hats gives a quite unique perspective into projects. And today I'll try to use this perspective to connect a thing that sometimes is too technology related and too focused on tools with actual business numbers and try to build from the business case to the technical implementation. So there's this one challenge. When you're building a business case, you have to have a problem. And usually no one wants to share their problem. And if you approach a customer, hey, I'm going to a conference, can I talk about your problem there? No. So I'm stuck with what we do at Entigo, and I have to use us as an example. No speaker notes. I'm screwed. A large part of what we do at Entigo is site reliability engineering. And the problem that we were looking to solve is scaling this business unit. It's extremely extensive on manpower. There are ways that you can, things that you can automate, but mostly you have to work with your head. So optimizing what we do there is important, and we saw that our practices were not good enough. So when talking about site reliability engineering, we focus on business applications. Just to be clear, Entigo is a service provider, and we provide site reliability engineering as a service. So these are the applications for our customers. These are not what we own. So we focus on our customer applications, and we focus on two user groups. First is the end users using these applications, and then we have product management and engineering. Our role is to make sure that the applications are reliable for end users and they can actually use it. And at the same time, we have to make sure that the developer experience is in place so that product management and engineering can rapidly deliver updates to these business applications. With our team, we support roughly 2,000 applications. So there are larger companies, but it's a bit. We do that with, by implementing processes and practices. So we help our customers get basic things like build and deployment automation in place, and sometimes we can go quite deep with all kind of compliance requirements and reporting and stuff that actually can be done with the data that we process there. Yeah, we have a technology challenge. I hope I remember what's the next slide. So to be able to do these processes, we need tools. It's difficult to automate something when you don't have the tool for the automation. So all the tools that we use and what developers use together integrated, this is what we call platform. And of course, all these business applications and tools need to need computing resources. So the infrastructure has to be there as well. Now, yeah. This part on the top, this is important. This helps business differentiate from the competition and win. The sad truth is that all the fancy stuff that we do at the platform layer, not many end users care about it. It's like electricity. It has to be there. But in reality, we'd like it to be just like commodity. You turn the key, it just comes out from the tap or something like that. So the problem that we discovered was that 25% of our team time was spent on keeping these platforms up to date. That is 25% of our valuable resources wasted on updating things that should be a commodity. And of course, after discovering that, we wanted to improve. So we used a tool from lean management called value stream mapping, and we tried to identify the processes or value streams where these resources were spent. First one was that we identified was setting up a new platform for a customer. And related to that was keeping this platform updated, doing the batch updates, component updates when something was released from upstream. Setting up a new platform is relatively straightforward. We have a platform template repository that we use. We fork this repository for new customers. Then we do a mapping at the customer. We try to understand what their requirements are for the platform, how the platform will integrate with their existing infrastructure, with their existing network setups, and so on. And we implement these requirements on top of this forked code base. And finally, we deploy it to their infrastructure. On average, setting up this new platform took around a day. So what we identified was that this nice fork strategy that we had is causing maintenance overhead at next steps. So why were we forking in the first place? The reason comes down to multi-tenancy and to the fact that we actually didn't know a better way. So we work with different corporations. They are using different cloud platforms. They have different policies, for example, how to protect their data and how to secure their networks. And they have invested into different tools. So although these platform deployments may look similar, there is pretty much they have pretty many customizations that make it difficult to reuse the same code base everywhere. And to make things even more interesting, since this infrastructure code base is usually owned by the customer, intellectual property rights won't let us share the code base too. So we get to the second value stream, implementing updates to the platform. What it means is that we need to monitor upstream software vendors. When they release an update, we need to pick it up. We need to understand if the update is backwards compatible, or if not, how do we migrate to a new version. We need to implement it in the infrastructure code base, test it in a production-like environment, and finally roll out to all customer environments. Most of the open source components that we use have a release cadence of once a quarter. Now, when considering batch releases, we have to do this for each platform deployment at least once a month. And to make things even more complicated, we have 2 teams that work on these updates on completely different Kubernetes platform layouts. So these teams are doing the same work in parallel and repeating it for multiple customers. To put this into the language of lean management, we identified 2 types of waste. First, relearning. Teams were not sharing their knowledge and technical implementations on the updates because they were working on forked code base and had diverted from each other. And rework. We had to maintain about 10 forks of the platform code base. This means re-implementing and retesting the updates for each fork. With that, we were ready to define our business case. So as we grow the company, we must find a way to make platform maintenance scalable. Looking at our existing customer base, the initiative would not deliver considerable savings at the moment. But when we put this into the perspective of our growth ambition, we see that within 2 years, we can reduce our unit cost 5-fold. So how did we do that? Well, first step was we tried to find inspiration from other fields who have solved this kind of issues before. And the closest one was software engineering. Over years, we've found inspiration from software engineering practices. And if you've tried to share code between different software projects, then you probably know that the worst thing you can do is copy the code from one project and paste it to the other, or fork the project. Fortunately, in this world, there's a concept called libraries. You can put the reusable part into a library, and you can import it to different projects. Similar to reusable software libraries, infrastructure as code tools have implemented their own package management and dependency management systems. And we were already using these. We were using Terraform modules to share the Terraform code, and we were using Helm charts. But there's one key concept that we were not using: interfaces. So why are interfaces important when talking about reusability? Yeah, this is extremely important when you're trying to share something. You want to have a stable contract with users. You want to have automated tests for that contract. Yes, but there's also a thing called polymorphism. In object-oriented programming, concepts like polymorphism make replacing part of the functionality with project-specific implementation easier. So we saw interfaces as key to making our platform components reusable. For example, when we deploy a Kubernetes, we need to know the subnets that will be used for hosting the worker nodes. We provide this information to the Kubernetes by referring to a VPC ID and to a list of subnets that this Kubernetes deployment should be using. Now, the VPC itself may have quite different implementations. For example, there may be a different subnetting scheme for different VPCs. The routing logic may be different. The connectivity to the corporate network and public networks can vary. So it's tricky to use one VPC implementation everywhere. But we could use interfaces to describe the data that is necessary for deploying Kubernetes. And as long as the VPC implementation follows this interface description, our Kubernetes implementation is reusable. Now, with interfaces and typing, we can use yet another pattern from software projects. Dependency injection. Instead of writing code to manually pass parameters between platform components, we can rely on dependency injection to do it for us. It helps to reduce the project code base, avoid human errors, and makes it easier to replace components with custom implementations. So with these concepts, we had an idea what to try out, and we were ready to move on to the implementation stage. We built a framework that helps us deploy and operate Kubernetes-based platforms at scale. We call it Infralib. So Infralib is made up of two parts. First, we have the modules or libraries, or how you want to call these. These are the reusable bits that you can use to build up your platform. We were already using Terraform modules and Helm charts, so we wanted to continue to use these. We rely on community-maintained versions, so we wanted to avoid maintaining our own alternatives. The second part is Infralib Agent. This is where most of the magic is implemented. It is a custom application that is used to configure and run pipelines that execute these modules and provision the platform. Where possible, we use cloud tools for the pipeline platform. For example, we use AWS Code Pipeline, and in Google we use Cloud Deploy. We try to avoid rolling our own solution wherever possible. Now, to customize this platform deployment, the platform engineer can define dependencies. These dependencies are actually a list of these reusable modules that the platform engineer wants to pull into their platform deployment. And it's also possible to configure these reusable components by providing your project-specific parameters to these. But what if we need to do deep customization for a platform deployment? We implemented a mechanism to define interfaces for these community modules. These interfaces are crucial. They help us achieve customization by enabling Infralib to offer multiple alternative implementation for a module. For example, when we want to deploy a CI server as part of our platform, we can have alternative implementation for a CI server. One based on GitLab, the other based on Jenkins. And the platform operator can choose which implementation to import as a dependency. And also these interfaces make it possible for platform engineers to create their own implementations if necessary. And this is what we see frequently necessary with VPC deployments. Now, the second part, agent. When we dig into how the agent works, there are actually two components to the agent. First is what we can call a compiler. What it does is similar to compilers in programming languages. It takes the user-defined input, it takes the modules, processes it, uses dependency injection, and will output pipeline and Terraform code that can be executed by the machine. And the second component is orchestrator. This is the bit that is responsible for running the generated code. What it does, it provisions your pipelines, it runs the pipelines, takes care of passing data between different pipelines or pipeline steps if necessary. And finally, out of that, you have the platform. So I promised you numbers. What's the impact of this initiative? We took 3 real-world projects and migrated these over to use InfraLib. And these were no example projects. 2 of these projects were in production since 2020. And when we calculated the average, by moving to InfraLib, we were able to throw away 88% of the infrastructure code base. Now, when I mentioned earlier that this focusing on the business application, focusing on these users and the developer experience, and getting your processes in place, this is the important part. Now, what I'm talking about is how to build a platform. So we've done it, and we saw that it's not an easy task to take on. So I'm happy to announce that we decided that we will be releasing InfraLib as an open source project. You can learn from our mistakes, or maybe you can even use it. And as of today, InfraLib is available under Affero General Public License. So what's the status of this project? It grew out of the code base that we've been using in production for 5 years. So we feel quite confident using it in production as well. And using it in production also means that we are committed to backwards compatibility where possible, or providing update paths if backward compatibility is not possible. Most of the technical concepts that I described, we've been able to validate these technical concepts. They are feasible. We can implement these, and they actually provide value to users. And for me, as a product manager, what I'm most excited about is the user base growth. Our teams are quite independent in their work and can select the tools they want to use. So we didn't want to force our teams to use InfraLib. The good news is that we are seeing interest among our internal teams. They see that InfraLib would help them become more productive and are actively adopting it for existing and new projects. Even better, we have first organizations outside of Entigo who are interested in InfraLeap. Having said that, InfraLeap is in active development. There is a lot that can be improved. And now, if you would like to get hands-on experience, what does it mean to provision a platform with InfraLeap, and what are the bits that are already in place? Martin, where are you? Yeah, there. Martin is hosting a workshop after the lunch, and you can do that there. Thank you.
Thank you. Let's take some questions. Congratulations on open sourcing such a large project.
Thank you. You talked about you're trying to use the cloud solutions for the code deployment. What do you feel about code commit deprecation in AWS? What you will use instead? Thank you.
The answer was S3 buckets from audience. Any more questions? In this case, let's give one more round of applause and thank you.
Thank you.